Hi, I am T. Kavita, Assistant Professor, Department of Mathematics. Today our topic is test of hypothesis, small test fish, F-test problems and solutions. What is F-test? The F-test is a statistical test used to compare two population variances or to test whether several population means are equal, that is as in ANOVA, Analysis of Variance. It is based on the F distribution, which is the ratio of two independent estimates of variance. The F-test is a statistical test used to compare variances of two or more populations. It is based on the F distribution and is widely used in hypothesis testing, especially in analysis of variance. Purpose of F-test. The F-test is used to compare two population variances, test whether samples come from populations with equal variances from the basis of ANOVA table, comparing multiple means. Formula of F-test, that is the F statistics is defined as F is equal to S1 square divided by S2 square, where S1 square is equal to variance of sample 1. That S1 square is the larger variance of sample 1, that sample is larger variance. S2 square is the variance of sample 2, that is the small variance. Always place the larger variance in the numerator so that the capital F value is greater than or equal to 1. The next, hypothesis. Here we define two types of hypothesis, null hypothesis and alternative hypothesis. Null hypothesis H0 is defined as sigma 1 square is equal to sigma 2 square, that variances are equal. Now the alternative hypothesis is defined by H1, sigma 1 square is not equal to sigma 2 square, variances are not equal. Then the F statistics formula, F is equal to S1 square divided by S2 square. The uses of F-test to test equality of two population variances, to verify the assumption of equal variances before applying t-test. In analysis of variance, to test whether several population means are equal. Next, degrees of freedom. Degrees of freedom in F-test. In an F-test, there are two degrees of freedom, numerator degrees of freedom and denominator degrees of freedom. Numerator degrees of freedom V1 is equal to N1 minus 1. V2 degrees of freedom of the denominator V2 is equal to N2 minus 1. Here N1 is the size of sample 1 and N2 is the size of sample 2. Thus the F distribution is denoted by F of V1, V2, where V1 and V2 are the two degrees of freedom. Steps in conducting an F-test. The first step is take the hypothesis, that is null hypothesis defined. H0 is equal to sigma 1 square is equal to sigma 2 square, variances are equal. The second hypothesis is alternative hypothesis, that is H1, that is sigma 1 square is not equal to sigma 2 square. The step 2 is compute the sample variances. Second step is we have to calculate the same sample variances. Third step, calculate the F ratio, that is F test. F is equal to larger sample variance divided by smaller sample variance. The fourth step is we have to find the degrees of freedom. We already see that formula, the degrees of freedom V1 is equal to N1 minus 1 and V2 is equal to N2 minus 1. Now the fifth step is compare the calculated F value with the table value at a chosen significance level. Now the last step, we have to conclude our conclusion. This is the first problem. The problem is two laboratories measure the concentration of a chemical in the same solution. Samples taken from each lab give the following results. Lab X size is sample size N1 is equal to 15, sample variance S1 is equal to 36, and lab Y value sample size N2 is equal to 13, sample variance S2 square is equal to 16. test at the 5% significance level whether the two population variances are equal. Here the critical value is given here. The F test critical value at 5% level. The sample size is n1 minus 1 degrees of freedom, 15 minus 1 is 14, and V2 n2 minus 1 is equal to 13 minus 1 is equal to 12. The critical value is given F 0.025, 14, 12 is equal to 3.206. The given values are n1 is equal to 15, n2 is equal to 13, and s1 square is equal to 36, and s2 square is equal to 16. These are the given values. Now we calculate. First we have to define the hypothesis. The null hypothesis is equal to h naught sigma 1 square is equal to sigma 2 square. The two populations variances are equal. The alternative hypothesis h1 sigma 1 square is not equal to sigma 2 square. That is, the two population variants are not equal. Here our test statistics F statistic is F equal to S1 square divided by S2 square. Here two samples are given. The samples values are 36 and sample variances are 36 and 16. 36 is the larger value, so we take as a numerator. Therefore 36 divided by 16, that is 2.25. Degrees of freedom is we already calculated. V1 is equal to 15 minus 1 14, and V2 is n2 minus 1 13 minus 1 is equal to 12. Now we calculate the F value. The F value is in the problem they given 3.206. We have to compare the value 2.25 and 3.206. Here 2.25 is less than 3.206. So we accept our null hypothesis. Our null hypothesis is two population variances are equal. Now we conclude at the 5% of level of significance, there is no significant difference between the variances of the two laboratories. Therefore, the population variances of lab X and lab Y can be considered equal. Thank you.